Okay, we're going to start our Usub homework. And again, we need to check the inside here to make sure if we do the derivative, we do get parts on the outside. And we do. So as usual, you're going to let u be the inside function, x squared minus 1, and du dx, that's going to be 2x. And again, we're going to multiply our dx over, divide by 2x. So du over 2x equals dx. And again, we do that because we're plugging in and replacing these values. So we have our integral. We have x times, we're going to have u cubed. And in place of dx, we know we need du over 2x. And so notice that we know we've made some pretty good choices because those x's will cancel. I'm going to take that 2 and move it out. So we'll have 1/2 times the integral of u cubed du. And so with our integration, we have 1/2 times u to the 4th over 4 plus c. And then you do need to change u back. And you can multiply those. So that's 1/8 times x squared minus 1 all raised to the 4th power and then plus c. All right, moving on to our next problem. And again, same process. Again, if we do the derivative of the inside function, we will generate parts of the outside. So u is going to be 2x squared plus 3. Du dx is going to be 4x, and again solve for dx, so we're going to have du over 4x equals dx. And then over here to the side we start plugging in. We have our x, and then we're going to have u to the 10th, and in place of dx we have du over 4x. And again, we see we did make the right choice. Those values do cancel. We can move our 1/4 out. And so it's 1/4 times the integral of u to the 10th du. So we're going to have 1/4 times u to the 11th over 11 plus c. And then we end up with 1 over 44 times 2x squared plus 3 all raised to the 11th plus c. So here's going to be your final answer. All right, moving on to the next. And again, hopefully you're seeing it's really the same process repeated quite a bit. Here's our inside function. If we do the derivative, we do have part of the outside. So again, u is going to be 3x cubed plus 7. Du dx is going to be 9x squared. And again, solving for dx, we're going to have du over 9x squared equals dx. And then we're going to go back up and check our substitutions. We have x squared. We have the cube root of u, and in place of dx, we have du over 9x squared. Those x squareds do cancel, and we move out our 9. So we have 1/9 times the integral of u to the 1/3 du. So we have 1/9 times u to the 4/3. So we have 3/4 u to the 4/3 plus c. And then we can go back and fill in. So we have, let's see, 3 cancels into 9. Leaving 3, not 2, my gracious. So that's 1/12 times 3x cubed plus 7, all raised to the 4/3, and then plus c. All right, so again, same stuff. Moving on to our next problem. And again, notice that our inside function would probably be this. And if I do the derivative, I am going to generate parts of that. So go ahead and let u be 1 minus 2x squared. Du dx is going to be negative 4x. And again, solving for dx, we have du over negative 4x equals dx. And again, we are filling in. So we have x over cube root of u. And then dx is du over negative 4x. And we see the x's do cancel. Negative 4 is going to come out as negative 1/4. And let's see, that's going to be u to the negative 1/3 du. And now we can do our integration. So we're going to end up with negative 1/4 times, and this is going to be u to the positive 2/3. So we're going to have our 3/2 here, and then plus c. And now the rest of it is just putting everything together. So we're going to have negative 3 over 8 times 1 minus 2x squared raised to the 2/3 power plus c. Okay, and again, this looks like it's the inside, and if we do a derivative, we are going to generate parts of the numerator here. So we're going to let u equal t squared minus 4t plus 3, and du dt is going to be 2 times t minus 4. And again, we do need to solve for dt, so we're going to have du over 2t minus 4, that equals dt. So we're going to plug back in. We have t minus 2 over u cubed. And then dt, we know that is going to be du over 2t minus 4. Now this, it's like, well, it's very close. So what we could do, let's factor that denominator, because it looks like we have a GCF maybe. And so if we do that, notice it's 2. If we factor that out, t minus 2. So we did get the right thing. So here, we're going to cancel out those t minus 2's as usual. Move out that 1/2. So we have 1/2 times the integral of u to the negative 3 du. And again, the same process. We're going to add 1 to the exponent. That tells us what to divide by, so that's negative 1/2 as well, plus c. And so putting everything back together, we should have a negative 1/4 times, and it looks like we're going to have 1 over t squared minus 4t plus 3, and that's all squared. And then we have our plus c. All right, moving on to the next problem. Again, we do need to check to see if we do the derivative here, and most of the time with trig functions it is going to be that angle, and it looks like it would be here. We're going to let u be 4x, so du dx is going to be 4, and again, solving for dx, we have dx equals du over 4. So we're going to integrate. We have 3 sine u, and dx is going to be du over 4. So notice now we actually have a couple of things. We have this 3 that can move out, and this 4, so that's going to make 3/4 times the integral of sine u du. And so that's going to give me 3/4, and let's see, if we integrate, we're going to get negative cosine of u, but we know u was 4x, and then plus c. Right, and just like our previous problems, this is probably what we're going to need to let u be. So again, we're going to say u is negative x cubed, and then our du dx is going to be negative 3x squared. We do need to solve for dx, so we're going to have du over negative 3x squared equals dx. And again, the reason why we're doing that, we multiply dx over, divide by negative 3x squared. And so let's go back and substitute in. We have x squared, and we have e to the u, and then dx is going to be du over negative 3x squared. Again, we see that our x squareds are going to cancel. Negative 3 gets moved out. So we have negative 1/3 times the integral of e to the u du. And again, that's going to be negative 1/3. And then if we integrate e to the u, we get e to the u. And I'm going to move back that u value and then plus c. Right? And so for our next problem, let's see, we can either divide this up into two individual parts, or we can integrate it like it is. I think it might be easier for us just to divide this up since it's just one term in the bottom. So if we divide this up, that's going to be 4 over e to the 2x minus the integral of e to the x over e to the x, so that's just 1 dx. And so for this one, we're going to have the integral of 4e to the negative 2x, and then minus just 1 dx, or the integral of dx. Either one's the same. So for this first one, we're going to have a u sub here. So we'll go ahead and let u be the exponent, negative 2x. So then du dx is going to be negative 2. And again, just like usual, we do need to solve these. So we're going to have du over negative 2 is equal to dx. And so here, let's go back and fill in. So we're going to have the integral of 4e to the u. Oh, that should have had a dx there, and I left it off. That is a dx there as well. And so in place of dx, we have du over negative 2. And so that negative 2 is going to cancel into 4, leaving negative 2. So we're going to have a negative 2 on the outside. The integral of e to the u du. And then we have minus the integral of dx, that second part. So we're going to have negative 2 e to the u, but we saw that we let u be negative 2x. And then minus, if we integrate dx, that's just going to be x again because it's 1. And then plus c. And we're going to continue on, and no matter how disgusting the problem looks, we are going to look at that as our u sub. So we're going to say u equals cosine pi x. And so du dx is going to be, and remember again, take the derivative of the angle, which is going to give us pi. And then the derivative of cosine is negative sine of whatever angle we were given. And again, solving for our dx, we're going to have du over negative pi sine pi x equals dx. And again, we're going to go back and do our substitution. So we have the integral of e to the u, and then times sine pi x, and then substitute in for dx, which is going to be du over negative pi sine pi x. And so again, we see we've made a pretty good decision because sine pi x and sine pi x do cancel. Remember, pi is just a number, so it can be moved out. And so we've really ended up with negative 1 over pi, since it was in the denominator, integral of e to the u du. And so we know that if we integrate e to the u, we get back e to the u, and our u value was cosine pi x plus c. All right, and moving on to our next problem, same thing here. We are going to let the exponent part be our u. And so du dx, we have negative 2x. And same pattern here, we are going to solve for dx. So we're going to have the integral of x times 3 to the u. And then dx is going to be du over negative 2x. And again, we see we made the right choice. Our variables cancel. Negative 2 comes out. It's on the bottom, so it's the fraction. Negative 1/2, and then 3u du. And this is the formula that we talked about earlier, how that will always be 3 to the u over natural log 3. And then I have plus c. And then we do need to go back and fill in what our u value was. And so putting all this together, we're going to have negative 3 to the negative x squared over 2 times natural log of 3, and then plus c. Now we have our definite integral, which means that we have our endpoints. But as far as our process for u substitution, that is not going to change. The inside function is what we're going to let u be. And then du dx is going to be negative 2x. Again, solving for dx, we see that du over negative 2x is dx. And when we come back over here, don't bring over the endpoints. We're going to adjust those here in just a moment. And then notice all of that under the radical is going to be our u to the 1/2. Dx is going to be du over negative 2x. And again, we see we probably made the right choice because those x's do cancel, and we're going to move out that negative 2. So we have negative 1/2 times the integral of u to the 1/2 du. Now we're going to find our new endpoints, and we do that by plugging in our old endpoints into our u sub. So for our top endpoint, if we plug in a 1, that's going to give us 1 minus 1 squared, or 0. And if we plug in 0 into the other, we're going to get a 1. And again, do note that our endpoints are backwards, so we do need to flip those, which is going to change this sign to positive. And now we're integrating from 0 to 1 of u to the 1/2 du. And so here we have 1/2 times, and then if we add 1 to the 1/2, we get 3/2, so our coefficient is 2/3, and we're evaluating this from 0 to 1. So it looks like we have 1/2 times 2/3, and then that's raised 1 to the 3/2 is just 1, and then minus 0. So it looks like we should have a solution of 1/3. Okay, so again, we will be letting the inside function be u. So we have u equals 1 plus 2x squared. Du dx is going to be 4x, and then solving, we have du over 4x equals dx. And then when we come over here to substitute back in, remember we have x over the square root of u, and dx is du over 4x. And again, those x's are canceling. We're going to move that 4 out. That's 1/4 the integral, and then we have u to the negative 1/2. But we need to go back and find our new endpoints. So if we plug in 2, we're going to have 2 squared, which is 4, times 2, 8, plus 1 is 9. And then if we plug in 0, we have 1. So now we're ready to integrate. We have 1/4 times, and that's going to be u to the positive 1/2 times 2. We're going to integrate that from 1 to 9. So here, since these will be working out, I would go ahead and cancel that 2 with that 4. You're most certainly welcome to do that, and it will make things easier. And then we're going to have 9 to the 1/2, which is 3, minus 1 to the 1/2, which is 1. So we have a 1/2 times 2, which is 1. Okay, and again, starting out the same way, we're going to let u equal 2/3 x, and so du dx is going to be 2/3. And solving for dx, again, we are multiplying dx over and then dividing. So we're going to have 3/2 du equals dx. And so coming back over here, substituting in, we're going to have cosine of u, but dx is 3/2 times du. So we are able to move out that 3/2. And then we do need to adjust our endpoint, so we can just go ahead and integrate. And so let's see, if we plug in pi over 2 down here, then that's going to give me pi over 3. And then if I plug in 0, I get 0. So that was a pretty nice little substitution there. So if we integrate, we have 3 halves times. If we integrate cosine, we get sine u. Integrate or evaluated from 0 to pi over 3. And so we have 3 halves times sine of pi over 3. Well, that's going to be root 3 over 2. And sine of 0 is 0. So it looks like we have 3 root 3 all over 4. Moving on to our next problem. Again, trying to figure out what we're going to let u be. And so with trig, if you've got your 2 trig functions, I would look and see which one I can take the derivative of and generate the other. And that's going to be our tangent. So I'm going to let u be tangent x. And so du dx is going to be secant squared x. And as usual, solving for dx, we have du over secant squared x equals dx. And we're going to make our substitutions. So we're going to have u to the 1/2 secant squared x. And dx is du over secant squared x. And again, we know we've made the right choices because those secant squareds are canceling out. And so we need our new endpoints now. We have u to the 1/2 du. And again, that's going to come from substituting in. So if we plug in pi over 4 for tangent of x, that's going to give us 1. And if we plug in 0, tangent of 0 is 0. And so now we're ready just to finish our integration. So we're going to have u to the 3 halves. And so 2/3 in the front, evaluated from 0 to 1. And so we're going to have, well, if I can get my pen to write, we have 2/3 times 1 to the 3 halves minus, and the other 0. So it looks like we're going to have 2/3. All right, and looking at number 15, more of the same. Again, I would definitely let this inside portion be our u value. That's going to be 9 minus x squared. So du is going to be negative 2x, du dx, sorry guys. And then we're going to solve for dx. So du over negative 2x equals dx. So up here, we are going to have x, and then times u to the 1/2 dx, but dx is du over negative 2x. And again, those x values are going to cancel out, so yippee, yippee, skippy here. Move out that negative 2, so we have a negative 1/2 integral u to the 1/2. Now let's find our new endpoints. Plug in 3, so that's going to give me 9 minus 9. And then plug in 0, we're going to get 9. So again, our endpoints are inverted, so let's swap those around. That's going to change our sign. So we have 1/2 integral from 0 to 9 of u to the 1/2 du. I forgot to write my du right there, sorry guys. And so we're going to have 1/2 times, and that's going to be 2/3 u to the 3 halves. And that's evaluated from 0 to 9. Again, I would go ahead and simplify here, and so that's really 1/3 times 9 to the 3 halves minus 0 to the 3 halves. So we have 1/3 times square root of 9, and then cube it, so that's 27, and 1/3 of 27 is 9. All right, moving on to the next portion. And again, it's an E problem, so that's pretty good because we know right away we're probably going to be our U sub there. It's going to be 1 minus x. So then du dx is going to be equal to negative 1. and change places. So we have, let's go ahead and write it this way. du over -1 equals dx. And of course that is the same thing as negative du, but I don't want it to confuse anybody. Here we're going to have the integral, and that's going to be e to the u, and dx is du over -1, so that -1 needs to move out. So we have negative integral e to the u du, and so we know here we got to adjust our endpoints. So if we plug in 2, we get -1. If we plug in 1, we get 0. Endpoints are inverted, so change your sign out here. And so it's going to be from -1 to 0 of e to the u du. Now we're ready to integrate. So we're going to have e to the u evaluated from -1 to 0. And so we're going to end up with e to the 0 minus e to the -1. So we're going to have 1 minus 1 over e. All right, let's move on to our next problems. Okay, number 17, not real sure why this is thrown over, well, I guess to develop the formula, but it's not necessary. Here, again, our formula tells us that will always integrate into 2 to the x over natural log of 2, and then that's evaluated from -1 to 2. So this is going to be 2 to the -1 over natural log 2 minus, my goodness, I did that backwards. That's 2 to the second, guys. I am so sorry. I think I'm trying to do too much at one time, my goodness. So that's 2 to the second minus 2 to the -1 over natural log 2. And then there you can leave it or fix it however your answer choices. One variation, you do have 4 over natural log 2. And then minus 1 over 2 natural log 2. Several different ways they could do this problem. So there's a couple of variations. All right, our next problem, again, very similar. Notice this cosine cubed, so that's probably telling me that I need to let u be cosine theta. So then du is going to be du d theta is going to be negative sine theta. Solving for d theta, we're going to have du over negative sine theta equals d theta. And so integrating from, instead of cosine cubed, we're going to have u cubed sine theta. And then d theta, that's equal to du over negative sine theta. So very quickly, again, we see we've made the right choice. We're going to cancel those out, move out that negative, and so we're really ended up with u cubed du. Now we do need to adjust our endpoints. So plug in pi over 2, cosine of pi over 2 is 0. Plug in 0, we get 1. So once again, we have our endpoints are inverted, so we do need to flip those back over, which is going to change that sign. So now from 0 to 1 of u cubed du, and so that's going to be u to the 4th over 4, evaluated from 0 to 1. So it looks like we're going to end up with 1/4. All right, let's move on. Again here, good u sub. Going to have u equals, my pen is about to quit, x squared plus 1, and then du dx is going to be 2x. Again, solving, we have du over 2x equals dx. We're going to integrate, we have x over u, and then dx is du over 2x. X's do cancel, that 2 moves out, so we have 1/2. It's the integral of 1 over u du, and we do need to adjust our endpoints, so plugging in 3, that's going to give us 10. Plugging in 1 is going to give us 2. So we have 1/2, and if we integrate 1 over u, that's going to be the natural log of u, absolute value of u, evaluated from 2 to 10. So we're going to have 1/2 times natural log 10 minus natural log 2. And they could go ahead and put those together. I kind of suspect they would. If you're subtracting with logarithms, that does combine to be division, and so that's really natural log of 10 divided by 2, which is 5. So there's another way you could see that answer. All right, and finally, number 20, we are going to let u be this exponent as usual. So u is going to be negative x squared. Du is going to be negative 2, du dx. It's going to be negative 2x. So du over negative 2x equals dx. And we're going to integrate. We have x, e to the u, and then du over negative 2x. Again, those x's are going to cancel. So those cancel. We're going to move out that negative 1/2. Integrate e to the u du, but we need to adjust our endpoints. So we're going to plug in the square root of 2. And so that's going to give me negative 2. If we plug in 0, that's going to give me 0. Again, got to change those endpoints. That's from negative 2 to 0 of e to the u du. And so we have 1/2 times, and again, if we integrate e to the u, we get e to the u, so we're going to have e to the 0 minus e to the negative 2. And so we're going to have 1/2 times 1 minus 1 over e squared. And you'll probably see the answer left like that.